Today we're going to be solving rationals. So we've done the operations on it. We've multiplied, we divided, we added, we subtracted. Now we're going to use those skills to solve rational equations. And we're going to focus on two main methods. The first one's going to be cross multiplication because I feel like you're going to be more comfortable with that one. And then for the second one, we're going to get rid of the denominator and solve. So we'll do those two main methods. We'll start with the cross multiplication. This is very similar to proportions you've done in the past. So does this represent an example of a proportion? Yes, it does, because we've got one fraction on each side of the equal sign. In order to cross multiply and solve the problem like a proportion, you can only have one fraction on each side of that equal sign. And so how do we solve a proportion? We cross multiply. So in this case, we would want to cross multiply. Here we multiply the 1 times 3 minus x, and that gives us 3 minus x. And then we multiply 4 times x plus 2. So we have cross multiplied like that. All right, now we are going to solve like normal since we do not have fractions here. We would distribute that 4 to get 4x plus 8. And now we want to get the x's together and the constants together. So we're going to add the x to get it to the other side. That gives us 3 equals 5x plus 8. We subtract the 8. I'm going to move over here because I've run out of some space, and I get 5x is equal to negative 5. My last step is to divide by that 5, and we get x equals negative 1. Now with rationals, you got to think about those exclusions we talked about, that you cannot have a 0 in the denominator. That makes our problem here undefined. So my domain restrictions would be when x is 3, because 3 minus 3 would make that 0, so x cannot be 3. And then negative 2 plus 2 would make that one 0, so x cannot be negative 2. Those are important because if your solution was equal to either one of those, then it would not be a true solution. Since negative 1 is not one of your domain restrictions, then it is your solution to the equation. All right, for the second example, we're going to use that same method of cross multiplication. But we said that we have to have one fraction on each side of the equal sign. In this case, that is not set up that way. We've got more than a fraction on this left-hand side. So the first step we would need to do is take these two and make them one fraction. And we did that when we added and subtracted last class. We put those two fractions to make one. So on here, the first thing we need to do is add 4 over x plus 7 over 1. Remember, all whole numbers are over 1. So we would get a common denominator. And I'll just go ahead and write it over here so I've got my whole problem. X would be the common denominator here, the least common denominator between those. I don't have to change the first one. For the second one, I need to multiply this denominator times x to get an x in the denominator. So I'm going to have to do the same thing to the numerator. So we get 7x over x. Now we can add, that would be 7x plus 4 over x. Remember, when you add, you keep the denominator and you add the numerators. So our new problem can be written as 7x plus 4 over x equals 2 over 3x. Now we have one fraction on each side, so we can go ahead and use that cross multiplication method again. We cross multiply here. So we get 2 times x is equal to 3x times 7x plus 4. Multiply numerator times denominator and numerator times denominator on the other one with that cross multiplication. Now we're ready to distribute. And that gives us 2x equals 21x squared plus 12x when we distribute. I'm going to bring this 2x to the other side because with quadratics, we always want it set equal to 0. So I subtract that 2x and I get a positive 10x. Now, since it's a quadratic, we have different methods that we use for quadratic to solve. We solve by factoring, we solve by quadratic formula, we solve by graphing and finding the zeros. You can do any one of those now to solve this quadratic. We're back in that section basically. I'm going to factor here. We can factor out an x, and so we get 21x plus 10. So this one here, x could be 0, or we can set this equal to 0, since they would both be multiplied together to give me a 0. I subtract 10, and I divide by 21. Now, remember to check for those domain restrictions. So if we think about the domain restrictions here, the only thing that can make either one of these 0 is if x itself was 0. So this first solution is not going to be a true solution. This is extraneous. And what that means is that is a solution to the quadratic, but it's not a solution to the rational. So we've got the solution because it is a solution to this quadratic. It is not a solution to our rational equation we were trying to solve. That's the reason why it's called extraneous for extra. This one, however, can be a solution since that's not part of my domain restrictions. So that right there is our solution. All right, we're going to move to the second method, which is clearing the denominator. And we'll look at the same exact equation we just did. So with clearing the denominator, you're going to do exactly what that sounds like. You're going to get rid of the denominators so that you can just work it like a regular problem. So we look at all three denominators, and we say 3 because remember whole numbers are over 1. And we look for that least common denominator. We already did that on the other side. This one's a little bit different. So our least common denominator between x and 3x here is 3x. X can divide evenly in there, 1 can divide evenly, and 3x can divide evenly there. So we find our least common denominator, which is 3x. We then take that and multiply that least common denominator times everything in our equation. And so we're going to distribute that into both sides of that equal sign. When we do that, we get 4 times 3x over x. Remember, all whole numbers are over 1, and when we multiply the numerators, we multiply the denominators. When we multiply it times the second one, we get 7 times 3x. And when we multiply it times the third one, we get 2 times 3x over 3x. All right, so here's why we did that. By multiplying it times the entire equation, we didn't change the value of the equation, we just changed the way it looked. But now we have an x in the numerator and the denominator, so we know that we can cancel that out. When we simplify, we have an x and an x in the denominator here, so we can cancel that. And we have a 3 and a 3 in both the numerator and the denominator, so we can cancel that. What we're left here with is 12 plus 21x is equal to 2. We've cleared the denominator. It makes it much easier to work with now because it's just like a regular equation that you've worked with before. We would subtract the 12. I'm going to move here. And so we get 21x is equal to negative 10. We divide by 21. X is equal to negative 10 over 21, which is the same thing we had gotten on the other side. So whether you use one method or the other, you're going to get the same answer. It's what do you feel more comfortable doing. All right, so we're going to look at a couple so that we can decide which method we want to use and what's going to make it easier. All right, when I look at something like this, I'm thinking clearing the denominator is going to be easier because you'd have to get a common denominator between these two to make them 1, which is going to probably make it a little bit harder before you cross multiply. To clear the denominator, first we simplify this, so we're going to want to factoring to our friend in this unit makes things easier. So we look for what multiplies to be negative 15 and adds to be 2. And that is a positive 5 and a negative 3. Now we find the least common denominator between all of them. Not because we're going to add or subtract, but because we're going to clear out all of the denominators by multiplying times it. So we need an x minus 3 for this one. We need an x plus 5 for this one. And then we need an x plus 5 for this one. We've already got one, so we do not need to use another one. And then an x minus 3. Again, we already have one, so we don't need to use another one. So we're going to multiply this entire equation times our least common denominator here. And again, that's over 1. When you multiply, you're multiplying the numerator times the numerator, the denominator times the denominator. And we are going to distribute this all the way through. So that's x times x minus 3, x plus 5, over x minus 3. So multiplying each one of these. We usually don't write the whole thing out, so we'll get used to not writing it out. But I want to show you what's going on here. So I am writing the whole thing out just so you can see it. So the x minus 3's cancel out. You've got 1 in the numerator, 1 in the denominator. The x plus 5's cancel out here. You've got 1 in the numerator, 1 in the denominator. And then the x plus 5 and x plus 5 and the x minus 3 and x minus 3 cancel there. So we've got nothing left in the denominators. They all canceled. We're left with x times x plus 5, 7 times x minus 3, and 24. We've got a regular equation we should be able to solve. So we've taken that really from Algebra 2 down to an Algebra 1 equation. We distribute. We combine our like terms. Since it's a quadratic, we're going to want to bring this over so that it's equal to 0. So I'm going to subtract that 24. And then our last step, of course, is either to factor, use the quadratic formula, or find the zeros with your calculator. In this case, I'm going to go ahead and factor. That's an easy one to factor. X plus 15 times x minus 3 is going to give us 15 and negative 3 multiply to be negative 45, and 15 and negative 3 add to be 12. And so the two things that can make this 0 are negative 15 and positive 3. Now, you want to remember those restrictions. Negative 15 does not make these 0, so that works. That is one of my solutions. The positive 3 would make this 0, which would make this entire thing undefined. So this is an extraneous solution. You would not want to include that in your answer choices. All right. For our second one here, and we said we're not going to write it out again, so I just want to show you how we're not going to write that whole thing out again. This is a good one to clear our denominators again because we've got two big fractions on each side here. So I'm going to multiply this whole thing times my least common denominator. I need an x plus 3 for the first one and an x minus 2 for the second one. And of course, they're over 1, and you multiply numerator times numerator and denominator times denominator. All right, so here we go. When I distribute this to the first one, the x plus 3's are going to cancel because you've got 1 in your denominator, 1 in your numerator. So that would be x minus 12 times x minus 2. So 6x minus 12 times x minus 2. When I distribute that to the second one, so we just did that one, we're going to do this one here. The x minus 2 is in my denominator and my numerator, so that is going to cancel. And I'm left with 5 times x plus 3. For the last one, nothing cancels, so we have to get the whole thing. Ooh, I was running out of space there. All right, so there's a lot of distribution that goes here, but we are done with the fraction part. So now we're ready to distribute. So we get 6x squared minus 24x plus 24 plus 5x plus 15 is equal to 6 times x squared plus x minus 6. And I'm going to have to distribute there one more time. And I'm going to go ahead and combine my like terms at the same time. So I've got 1 x squared term, 6x squared. I've got a negative 24x and a 5x, so that's going to give me a negative 19x. And I've got a 24 and a 15. That's going to give me 39. And then I distribute here, and I get 6x squared plus 6x minus 36. Now, since it's a quadratic, we're going to go ahead and get everything to one side. When I do that, and I subtract the 6x squared to get it to this side, they both cancel out. So this one's actually going to be a little bit easier than the ones before. And so I've got negative 19x plus 39 is equal to 6x minus 36. Now we got to get them both onto the same side. So I'm going to add the 19x, and we get 39 is equal to 25x minus 36. We add the 36, and we get 25x is equal to 75. So x is 3. When I check my 3 here, 3 plus 3 would be 6, and 3 minus 2 would be positive 1. So this is not part of my restrictions. These are solutions, so this would be my answer. 3 is equal to x. All right. If you want a little cheat with rationals, or with any equation really that has an equal sign, we can always use the calculator to solve. So I am going to go ahead and throw that in here just so you see that. If I hit alpha y equals numerator over denominator, I can get a fraction. And then we can put in exactly what we see here on the left-hand side. So I put the left-hand side of my equation into y1, and in y2, I'm going to put the right-hand side of my equation, which is 6. And either side could go into just one side on y1 and the other one into y2. Now we're going to hit graph. It's taking its time here. Rationals have kind of strange graphs, but there is our graph. So this right here is the 6, that red line. And then you see a little piece of the rational up here, and it's got another piece here and another piece here. But the one that we care about for the solution is where they intersect. That's where this rational is 6. It's where they're both the same. So we hit second trace intersect. And then you want to make sure you move your little cursor there to be on the correct graph. And so there it is. And then you hit enter, enter, enter. And there is our intersection at 3, which is exactly what we found here. So if you use your calculator, you can check your work there to find that intersection. If you were using Desmos, same thing, you can put it in Desmos and click on it to find the intersection. All right. For C, this is one that you can go ahead and cross multiply with. Since they have the same denominator, I can just go ahead and subtract the 5 over x to get it to the other side. Now for this one, we keep the denominator and we add or subtract the numerator. So 5 minus 5 would be 0. So actually this comes out to be 0 equals 25. And so that is not a true statement. So this has no solution. So that's what a no solution would look like on a rational. All right, for D, this is another good one to cross multiply because it's got one fraction on each side. So we're ready to cross multiply here. So we get 5 times x minus 5 equals x squared plus 2x minus 35. Again, we can cross multiply this because there is one fraction on each side. That gives us 5x minus 25 is equal to x squared plus 2x minus 35. Since it's a quadratic, we want to get everything to one side of the equal sign, so I'm going to subtract the 5x and add the 25. We do the opposite to get them to the other side of the equal sign. And so we get x squared minus 3x minus 10. It's a quadratic, so factoring, lots of factoring the rational unit. Hopefully you're getting really good at it. That would be x minus 5 x plus 2, because negative 5 and positive 2 multiply to be negative 10, and negative 5 plus 2 gives us that negative 3. And so the two possible solutions are 5 and negative 2, because that's what makes each one of these 0. 5 minus 5 and negative 2 plus 2. Now remember, we always have to go back and verify that those are not restrictions. And so our restrictions here, we got to factor that. That would be x plus 7 and x minus 5. And so our restrictions are 5 and negative 7. This one falls with our restriction, so we do not want to use that as one of our solutions. X equals negative 2 is our only solution. That's what we would want to put down on an answer. So there's our basics on solving rational equations. You're going to want to practice.